Now, most of the time, or often, we're going to be dealing with ellipses that are not centered at the origin. So we have, they'll be at HK is the center of it. And you might just imagine, as we've done with shifting of functions before, when we did other, in Math 126 or pre-calculus, it's similar here. So the standard form of the equation of an ellipse centered at HK and major axis parallel to the x-axis is x minus h squared over a squared plus y minus k squared over b squared equals 1, where a, again, a is bigger than b. Length of the major axis is 2a. Coordinates of the vertices are h plus or minus a comma k. Minor axis is 2b. The coordinates of the minor axis of the co-vertices, I should say, are h comma k plus or minus b. And then the coordinates of the foci, since it's on the major axis and that's horizontal, h plus or minus c comma k, where c squared equals a squared minus b squared. So the standard form of the equation of the ellipse that's centered at HK and major axis parallel to the y-axis is, notice the a squared is under the y part. So again, a is bigger than b. Length of the major axis is 2a. Length of the minor axis is 2b. Coordinates of the vertices are h comma k plus or minus a. Coordinates of the co-vertices are h plus or minus b comma k, because that's going to be on the, on the horizontal versus this on the vertical. And then the coordinates of the foci are h comma k plus or minus c, and I got to put that in there twice, so delete that part. Or again, c squared is a squared minus b squared. Okay, so just as with the ellipses centered at the origin, ellipses that are centered at the point HK have vertices, co-vertices, foci. So it's got all the fun stuff, vertices, co-vertices, foci, that are related by the equation c squared equals a squared minus b squared. We can use this relationship along with the midpoint distance formulas to find the equation of the ellipse in standard form when the vertices and foci are given. So here it is, it's not centered at the origin. Here's a graph or a drawing of each of these. Okay. So how to write the equation of ellipse in standard form given the vertices and foci and not centered at the origin. Determine whether the major axis is parallel to the x-axis or y-axis. If the y-coordinates are given of the vertices and foci are the same, if the y-coordinates of the given vertices and foci are the same, the major axis is parallel to the x-axis. Use the standard form here. So that is, so if what you're seeing is like 5, 2 and 3, 2, that means it's moving horizontally for the vertices and foci. So it's going to be like that. If the x-coordinates of the given vertices and foci are the same, the major axis is parallel to the y-axis. Use the standard form x minus h squared over b squared plus y minus k squared over a squared equals 1. A little bit bigger. Identify the center of the ellipse HK using the midpoint formula and the given coordinates of for the vertices. You could also do the midpoint of the between the foci. Find a squared by solving for the length of the major axis. 2a, which is the distance between the given vertices. Find c squared using h and k. Found in step 2 along with the given coordinates for the foci. Solve for b squared using the equation c squared equals a squared minus b squared. Oh, there's a 6th step. Boy, it would be nice if those could all be on the same page, but I guess they're not. Okay, substitute the values for h, k, a squared, and b squared into the standard form of the equation and go to town. So for this one, we are looking at the standard form of the equation of the ellipse that has vertices negative 2, 8, negative 2, negative 8, negative 2, 2. So what's changed here is the y part's changed, the x part stays the same. So that tells us this has a vertical major axis. Okay. And so it's going to be x minus something squared over something plus y minus something squared over something equals 1. So we need to find 1, 2, 3, 4 pieces of information. And pretty quickly we can find the center. We can find the h and the k. It's going to be this midpoint here. In fact, it's going to be a -2 for the x. So what's midway between -8 and 2? So -8 plus 2 divided by 2 is going to be -6 over 2, which is -3. So that makes sense. From -8 to -3 is 5. From -3 to 2 is 5. So that's going to be 3 negative. And so like I said, if our center is at -2, -3, and a vertex is at, let's just go with -2, 2. Well, we want to know how far apart those are. So how far is it from -3 to 2? So 2 minus -3 is 5. So a must be 5. So a squared is 25. That's going to go here. Now if we look at the foci, how far is it from the center to one of these? So if we look at for foci, going from -2, 1 to -2, -3, that's 1 minus -3 is 4. So c is 4. So we're going to use c squared equals a squared minus b squared. So 4 squared equals 25 minus b squared. So 16 is 25 minus b squared. You can subtract the 25 from both sides. So -9 equals b squared, negative b squared. So b squared is 9, or b is 3. All we would need is b squared is 9. So let me clean this up a little bit. I know there's not a lot of space. So it's x plus 2 quantity squared over 9 plus y plus 3 squared over 25 equals 1. There you go. Okay, and then our next thing is going to be graphing ellipses centered at the origin. Yay.